All right, so yesterday we started the main idea of function notation. And in fact, the first part of this problem right here is what we talked about yesterday. It's the second part that is the new part that finishes off this idea. So just to refresh your memory, when we have f of negative 10, and I'm simply writing it over here because that's too small for me to write next to on my iPad here. But the negative 10 is the input. In other words, the x value that we are inputting to our function here. So in other words, negative 10, of course, is input right here to find the output. By the way, I would like you to figure out the output right now. So of course, to figure that out, it's negative 2 times the input, which is negative 10, minus 3. So that's 20 minus 3, which is 17. So our output, when the input is negative 10, is 17. And of course, we should be doing some writing in our notes. We all have the same number 1 here. Okay, but that part was easy, right? Because that's what we did yesterday. That's what we did yesterday. So we can go ahead and put 17 in here. It's the second part that is the new part here. So now I'm giving you the output. And you have to find the input. That's one way of looking at it. The other way of looking at it is, look, f of x is equal to 1. So coming up to here, f of x is equal to 1. So essentially, and I know it's hard to see that 1 there, essentially we have a two-step equation that is 1 is equal to negative 2x minus 3. So we're trying to find the input when the output is 1. Could you go ahead and figure that out, please? So what is the output, or input, excuse me. We were given the output. What's the input? Negative 2. So we add 3 to both sides, and then divide both sides by negative 2, and we get negative 2. So let's go ahead and put that in. So when the output is 1, the input is negative 2, and we submit, and we got it right. Okay? So now you click on number 2, and do number 2. Which is not in your notes. You're just going to do that right here, but it's the same type of situation as number 1, and I'll get back to you in about a minute. All right, so let's take a look at this one. In the first part of it, which is what we talked about yesterday, the input is 4. We're trying to figure out what the output is. So we have negative 9 times positive 4 minus 2, which is negative 36 minus 2, which of course is negative 38. And so let me take my writing off of here and input negative 38. Is that what I said it was? Negative 38? Okay. And then in the second part, this time we're given that the output is negative 83. In other words, f of x is negative 83. And then we solve that two-step equation by adding 2 to both sides, which gives us negative 81 equals negative 9x. And so clearly x would be equal to 9. So that means the input is equal to 9, and we can see that that is correct. All right, so that's pretty easy. The other three new types of problems are really based on the same idea, but in different situations. What if instead of me giving you an equation, I give you a graph? One option is you could figure out the function rule for that graph and do it the same way you did in number 1 and number 2. But I wouldn't do that, because that requires more work. Instead, let's think about it in terms of looking at the graph. So in the first part of this question, we're saying, well, evaluate f of negative 1. So when the input is negative 1, what is the output? Well, when we take a look at a graph, this axis is typically our x-axis. But it's not just our x-axis. it's also our input axis, and you might want to write that in your notes. We could also consider it to be the domain or the independent variable. But in terms of function notation, let's think of it as our input axis. So when the input is -1, well, this is where the input is -1. So the question might be this. When the input is -1, what is the second part of the ordered pair that completes that lies on the graph? What would it be? It would be -3, exactly. Very good. Because right here is where the input is -1 on the graph. Now here's one other thing you could do. You could just find the input, go straight down until you hit the graph, and then go over here, and we can see that our output is -3. Okay? All right, so over here, -3. Now we're going to flip the process. What if instead the output is +3? What is the input? Well, we could do the same kind of thinking. When the output is +3, what is the input? Well, we find the ordered pair on the graph that is something, 3. So what would the input be in this case? Just tell me, please. It would be +2. You could also just locate it on the graph. So right here is where the output is 3. So if we go over to the graph and straight down, we end up at +2. So you can think of it in terms of ordered pairs or solutions that lie on the graph, or just going up and over from the graph. But regardless, the input when the output is 3 is +2. All right, go ahead and click Submit and try your number 4, which is the same kind of problem. All right, so let's take a look at number 4. Number 4, same sort of idea here. I'm going to do this instead of looking at ordered pairs. I'm just going to do them actually on the graph. And so, hold on a second. I need to move this up a little bit. All right. So when the input is -1, which happens to be right here, if I go up to the graph and over, I can see the output has to be +1. And then, when the output is +3, well, the output is +3 right here. So if I go over to the graph and down to the input axis, I can see it has to be +1. Is that correct? Yes? All right. So let me go ahead and put both of those in. 1 and 1. It just so happens to be that they are the same. Okay, so let's go to number 5. Number 5, you're given a table. Now, before we start thinking about inputting answers, by the way, this is a picture. The answers will actually go down here. Okay? All right, so f of 6 is equal to something. So when the input is 6, well, these values all right here, all of the x values are the inputs. So all you have to do is find where the input is 6 and then locate the output. So when the input is 6, what is the output? Tell me, please. Yeah, because it's that ordered pair right there. So it is -94. So that's what I was saying earlier. With tables and graphs and ordered pairs, it doesn't really require any work. So now we're going to do the flip of that. And this is the first one that we did. So now when the output is 64, this f of x values or y values are the output. So when the output is 64, what is the input? Tell me, please.
2.
It's 2. So you're locating this ordered pair right there. Okay? So let's input those, click Submit, and then you go ahead and try the next problem. Okay, so let's take a look at the next problem, which is number 6. And your number 6 is the same as mine. So first problem, when the input is 4, remember, these are the input values. What is the output? Well, that would clearly be 89. And then, if I give you the output being 86, that would be right down here. When the output is 86, the input is 8. So 89 and 8. Well, a table of values is really just representing a bunch of ordered pairs. So I really shouldn't even have to explain how to do this one. Can I go ahead and have all of you try this one? And once again, the reason why I shouldn't need to explain is because the tables found in 5 and 6 were just a way of representing a bunch of ordered pairs. So let me ask you now, when the input is 2, what is the output? It's 2, because this is when the input is 2 right there, so we're utilizing that ordered pair, so the output is 2. In the second part, when the output is 16, what is the input? Tell me. It's 14, good, because right there is the ordered pair where the output is 16, so the input would be 14. All right, you go ahead and do number 8, and then I have one last little thing to talk about. All right, so that should have taken about 15 seconds. F of 2 is equal to what? Tell me. 0, because we're looking at this ordered pair right there. When determine x, when f of x is equal to 10, so what is that value? 12. It is 12, because now we're looking at when the output is 10, that will be that situation right there, and that would be it. Okay, last idea for today, because this is part of the small part 2 assignment. So yesterday we talked about how to fill in ordered pairs based on an equation here. The new thing is I'm adding whether the situation is a function or not. For some of you, you may need to do the graph to do that, or you may be able to just look at the ordered pairs. The new thing is I'm actually having you graph 2 problems in part 2 in my open math. So first of all, look at all of the tools down here. We have the line tool, the parabola tool, the V tool, and exponential tool. Which one are we going to need for this graph? We talked about that yesterday. The V tool. So look, once you know what kind it is, you'll select that. You, of course, as it says right here, you need to plot all of your ordered pairs or you're not going to get full credit. So you'll plot them, and then you'll use the V tool, which this one happens to be right here. And most of you could figure that out, but I just wanted to kind of show you that. So on parabolas and lines and V's, we haven't done exponential yet, but you'll need to make sure you select the right tool to graph them. Okay?